All right, let's look at number 3. The explosive TNT has the molecular formula C7H5NO2 3. How many elements make up this formula? Well, there's carbon, hydrogen, nitrogen, and oxygen. There are 4 different elements. Okay, there are different numbers of atoms of each of those elements. That's most certainly true. But in terms of the types of elements that are present, there are 4. B, how many oxygen atoms are present in one molecule of C7H5NO2 3? So when we look at these subscripts here, we see this parentheses around the nitrite. Okay, if you look at your polyatomic ion sheet, NO2 is nitrite. We're going to see that this subscript 3 on the outside of that polyatomic ion indicates that there are 3 of those polyatomic ions. And so if each polyatomic ion has 2 oxygens and there are 3 of them, we multiply those together and we get 6 oxygen atoms. C, how many atoms in total are present in one molecule of C7H5NO2 3? So in B, we were asked how many oxygen atoms are present in one molecule. Now we're being asked how many atoms total. Now when we go over here, we get 7 carbon atoms, then an additional 5 hydrogen atoms, so we're up to 12. And this last step is where I saw some mistakes in class, if mistakes were in fact made. We remembered that we had 6 oxygen atoms from B. So we would bring the 12 atoms from out here. We would add 6, right? That would get us to 18. And then you students, oh so smart, you wouldn't forget the nitrogen, so that'd be 19. The mistake here is remembering that this subscript 3 outside of the nitrate refers to everything inside the parentheses, not just the oxygen atoms that we dealt with in B. And so, yes, we have 7 carbon atoms. We have 5 hydrogen atoms to bring us to 12. We have 6 oxygen atoms to bring us to 18. But remember, we have 3 nitrogen atoms as well. Okay. We have 3 nitrites, and for each nitrite, there's 1 nitrogen atom, so that's 3 nitrogen atoms. That's going to bring us to 21. Now, D here, right, brings back one of our old friends, okay, the crosshairs, conversion factors. So let's try to refresh our memories about how to do this type of calculation. How many atoms are present in a sample of 2.0 times 10 to the 23rd molecules? Now, before you start asking yourself, well, do I times this number by that number? Do I times this number by that number? Remember, I don't want you to be asking that question. I want you to be focusing on how to set up your crosshair, your dimensional analysis, such that the units that you do not want present in your answer cancel, and the only unit that is left is the unit that you want in your answer. So the question gives us molecules. It gives us this value, this number of molecules. So we're going to start with that number that the problem gave us, molecules being the unit. Now, I'm going to put molecule on the bottom for sure, on the denominator for sure. Why? Because I need them to cancel out. Now, I want to be converting into atoms as a unit because the answer is asking for how many atoms present. Right? So that's what my answer needs to be in terms of. But I need some statement of equality that will relate number of atoms and molecules to one another. Luckily, in C, I did just that. In one molecule, there are 21 atoms. So I can have molecules as the denominator unit, atoms as the numerator unit, and I can have 21 atoms per one molecule. Notice what this does. It allows the molecules to cancel each other out. My only unit left is atoms, which is what I want my answer in terms of. Now, for all of you who are just asking, I just need to know what numbers to times. You are missing the point entirely. If you set up these crosshairs and focus on your units first, the crosshairs will tell you what to multiply and what to divide. Notice these two values are side by side in the numerator. That indicates a multiplication. So we will multiply 2.0 times 10 to the 23rd by 21. Now that's going to come out to be 42 times 10 to the 23rd power atoms. Now that's a number. That's perfectly acceptable as a number. It's a value. It's real. However, it's not in proper scientific notation. So before I go to write down my answer over here in my answer box, my answer area, I'm going to move this decimal place so that instead of a 42, it's 4.2, right? Because remember, in proper scientific notation, that that coefficient value has to be between 1 and 10 somewhere. So 4.2, I moved the decimal one place to the left, so I'm going to increase my exponent over here by 1. So I'll have 4.2 times 10 to the 24th atoms present in one molecule.